All right, so I'm going to quickly give you an overview of the definite integral. Let us understand the concept of signed area first, right? And then we will talk about, what is definite integral. So I'm just sort of building some background around it. So if we have, let's say, a curve like y equals to x plus 1, and I have to, let us say, this is minus 2, and let's say this is plus 2. I have to find the area between minus 2 to 2 for this curve. So what is the area that is being covered by this graph from minus 2 to 2? So if I were to shade it, this area, and then all of this area, and all of this area. Correct? So that's basically the area that is the area under the curve. Now, when I say under, obviously, when we have the positive x-axis, it is basically under because the graph is over. And when we are in the negative side of x, I mean, obviously the area is over the curve, not under. But then that's how the graph is, right? I mean, when the graph slides under x-axis, the area is over between the x-axis and the graph. So area under the x-axis, whenever you say area under the curve, it is a very generic term. So it means area between the x-axis and the graph. That's about it. So if it is going in the negative side of x, it's sort of area over the curve, not under, if I have to really use that, what do you call, the English terminology, right? And if it is on the positive side of x, we call it as area under the curve. Now, coming back, and let's say this is minus 1. Now, if I have to find the area under the curve or area between x-axis, and I need to find the area of the shaded portion, which is yellow. This is basically divided into two triangles. If I find the area of this triangle and I find the area of this triangle, I should be able to find the area between x-axis and the graph, or area under the curve. Let's try to find the area of this triangle. And I call this area as A1 and this area as A2. So let's find A1 first. A1, half base times height. So let us say this is 3. So height is 3. How much is the base? If this is 0, so this is 2 and another 1. So base is 3. Ignoring the negatives. So the area of triangle A1 is half base times height, which is 9 on 2 units. Now, what is the area of A2? Ignore the negatives for a second. What would that be? That is half. Base is 1. And let's say this is also -1 here. So the height is 1 as well. So half times 1 times 1, which is Half times 1 times 1 is half units. So what is the total area? Total area is A1 plus A2, which means 9 on 2 plus half, which is 10 on 2 of 5 units, 5 square units. Square. 5 square units. It's the area. That's the total area. Cool. Now, let's put some let's put some restrictions around it. Let's say, okay, area which is over x-axis is positive, and area which is under x-axis is negative. So then what? Then this A2 is actually negative A2. Why? Because it is sitting under x-axis, right? Whereas A1 is a positive A1. So then what will be my total area? My total area will be A1 plus minus A2. Considering that I now have put this condition to find the area. Finally, this becomes A1 minus A2, which is nothing but 9 on 2 minus half is 4 square units. This area, which takes into the account the positives and the negatives given if it is sitting over x-axis is positive, sitting under x-axis is negative, is not called total area anymore. Since I have signs associated with it, I call it as signed area. So that's the difference between total area and signed area. Total area does not take into account whether the area is above or under x-axis, it just adds up the areas, whereas signed area takes positive and negative based on whether the area is sitting over or under respectively. Now, if I have a curve like this, if I have a curve like and this is y and this is x and this is origin. So what is my area under the curve? I have this, then this, then this, and this, right? So I call them as A1, A2, A3, A4. Now, what is my total area? Total area does not take into account the positive and the negative. So that means A1 plus A2 plus A3 plus A4. Simple. And what is my signed area? A1 is positive, A2 is negative, A3 is positive, A4 is negative. That is my signed area. So that's the basic of how the total area and signed area works together. Now, I will still take the example, I will still consider this example and I'll connect the dots, right? Now, when we talk about definite integral, let's understand what is indefinite integral. Indefinite integral is what we've been doing so far. Whatever we've been doing so far. So if I say x squared dx, what is x squared dx? X cubed over 3 plus c. This is indefinite integral. I don't have boundaries to it. This, the answer is still a variable, x. So the moment I define my boundaries, I'm actually assigning values to this x, and hence I am getting down to a definite value, a real number. And that is why it's called definite integral. So if I now put some boundaries and I say from 0 to 1, x squared dx, it is actually telling me to find the area under the curve from 0 to 1. Find me this area. It helps me find this area between 0 to 1. Whereas if I don't define the boundaries, it will still give me an area under the curve, but it has no bounds. So you have to enter boundaries to get to the definite value of the area that you are after. Now, how do I get to know the area under the curve which between 0 to 1 for x squared dx? I don't do anything that is new. I'll exactly do this plus c. But now I have these boundaries. So I'll say 0 to 1. So the fundamental theorem of calculus tells us, so I'll not go into the real sort of derivation of how fundamental theorem of calculus was defined and derived, but I'll simply connect the dots here. So the fundamental theorem of calculus tells us that if you have a function f of x between a and b, and that function is a continuous function, that means there's no breakpoint in the function. It is a continuous function between a and b. Then you can find the definite integral between a and b f of x dx is, you find the integral of f of x. Let's say that integral of f of x is g of x. Let's say. So I will say g of x between a and b, which is equals to, I sub in the top limit first, g of b, and I subtract it from the, by subbing the bottom limit in the integral. And this will be the area under the curve for f of x dx. Now let's apply this rule, the fundamental theorem of calculus, to this integral that we have found for x squared dx and try to do it. So my x squared dx between 0 to 1, this area that I'm now trying to calculate, I found the integral to be x cubed over 3 plus c between 0 to 1. So fundamental theorem of calculus tells me, first of all, sub in the top limit in your integral. What is the integral that I have? X cubed over 3 plus c. Let's sub in 1 here first. So 1 cube minus 3 plus c. C remains c. Take away g of a. Please put a bracket because it's a negative. And it will have a knock-on impact. Anything which is negative becomes positive. Anything which is positive becomes negative because you got negative outside. And I plug in a here, which means I plug in 0 here. 0 cube over 3 plus c. And I just solve it now. Let's solve it. 1 cube is 1 over 3 plus c minus 0 minus c. And you see now your c is cancelled. So there is no need to write C because every time it will get cancelled. So there is no need. And that is why here you don't have a C because C always gets cancelled because of this negative in the front. You getting my point? Why C is not written? We'll still write it down for the sake of completeness, but no need to write. If you have to, and I'll change the color of my pen, if I have to just do it without C, I will simply say, okay, plug in 1 cube minus 3 minus, plug in 0, 0 cube minus 3. That's about it. And you actually land at the same spot. C is not required. So let's take this forward. So I'll probably, continue here. So this will be then 1 on 3 minus 0, which is 1 on 3 square units. So the area under the curve between 0 to 1, this shaded portion is 1, 3, 1/3 square units. And that is what definite integral is all about. Now, let's connect the dots between signed area and total area and see. We just proved that, or we just sort of understood that the definite integral gives us area under the curve, which is cool. But at the same time, at the start, I told you there are two types of areas, signed area and total area. So what exactly is definite integral giving me? Signed area or total area? I don't know. Let's understand that and let's try to find it. So I go back to this example here. And I'll redraw this example and I'll redraw this graph here quickly to now find the area under the curve using definite integral rather than the triangles. And then we will see if whether we are getting a 5 or we are getting a 4. If we are getting a 5, that means definite integral gives us total area. If we get a 4, that means definite integral gives us signed area. Am I making sense so far, everyone? Right? Okay, now let's draw the graph again. Got this. This is -2, and then what was it? This was -2. No, this is -1. Sorry, -1. This is -2. I say this is 2, and this is 0. Right. And we were after this, all of this, not under O, basically. Right, not here. This one. Let's try to find it using definite integral. The equation of the line was y equals to x plus 1. So now I'm going to find the definite integral because area under the curve, the yellow portion, is also given by the definite integral between -2 to x plus 1 dx. Let's try to find it. Now I can divide it into two parts if you really want to. You can do it like this. You can do it like this. You can break the integral, right? You can break the integral, right? So if you have f of x plus g of x in an integral, you can break it into f of x dx plus g of x dx. That's exactly what I've done here. But this time I just have limits on top. I've got the boundaries. Okay. So what is the integral of x dx? X squared plus 2 between -2 and 2. Correct? And what is the integral for dx? Just x. Right? negative 2 to 2. Is that clear so far? Everyone's fine, right? Now, let's plug it in. And I'm not going to write c this time, okay? 2 square over 2 minus minus 2 square over 2. All good? Plus 2 minus minus 2. Right? Let's solve it. 4 on 2 minus 4 on 2 plus 2 plus 2, which this is 0, which becomes 4. And what was 4? 4 was the signed area. So the point that I'm trying to make here is that the definite integral, whenever you are solving area under the curve, the definite integral will always give you signed area. As simple as that. Is that clear? So that, in a nutshell, is what definite integral is and how it gives us the signed area. All right? Cool. Thank you.